I think I'm recording. Okay. Why is it small like this? No, not what I want. Okay, here we are. Okay, you see here it wants to know what type of bond. So when they want to know bonds, you're going to take electronegativity differences. So we need P and Cl. So if you go to table S, Cl is right here is the electronegativity difference. It's 32. Wait, I want to show you. See, it says electronegativity. Cl is 3.2, and phosphorus is right here, which is 2.2. So then all you have to do is 3.2 for the Cl and then 2.2. And when you take the difference, it's 1. And from 0 to 0.4 is basically nonpolar. So this one has to be polar. Plus, you know it's covalent because it's two nonmetals, because they're both on the right side of the table. Okay. Now, what type of bonding is found in HBr? Well, H is a nonmetal and Br is a nonmetal. And then if you go, because they're asking bonding, you look up electronegativity, you have 2, and then for Br, it's 3. It was 2.2 and 3. And then you take the difference, 3 and 2.2. So the difference, you just do big number minus small, so you know it's 0.8, so it's polar covalent. You knew it had to be covalent because even though H is on this side of the table, it's a non-metal. Okay, all these guys are metals, but H is separated, so if you have non-metal, you know it's covalent. Good. Mobile electrons. Right in the word metal. Metals conduct due to mobile electrons. Good. What type of bond is in water? Well, water's H2O. I know water's polar, but anyway, you look up the electronegativity value, so you go to table S, because when they want bonding, that's what you do, and if you see here, it's 3.4. H is 2.2, and then you do 3.4 minus 2.2, so you get 1.2, so you know polar is like 0.4 to 1.7, the difference. Now copper, if you look at copper on the periodic table, you probably know already copper is a metal. Anything on this side of the stairs is a metal except for H over there, that's a non-metal. But because copper is a metal alone, I say right in the word metallic. Metallic is a metal, Al for alone, so it's a metallic bond. Now here, 2 chlorine molecules. It says 2 chlorine atoms. When you have 2 chlorine atoms, we looked up chlorine before. It was actually this number, the 3.2. 3.2 minus 3.2, what's the difference? It's going to be 0. All diatomic, which is 2 of the same, is going to be nonpolar, because nonpolar means the difference is 0. Now, I teach TICs. Transfer of electrons is ionic, and covalent is sharing. So you see here it says transfer of electrons. I'm going to pick ionic. Now here you have Mg, S, and O. Now let's see where it is on the periodic table. Mg is over here, so it's a metal. S is on this side, so it's non-metal. So you see how you can have your periodic table open. So if you do metal, non-metal, if you have 3 things, you're going to say both ionic and covalent, because 2 non-metals make up a covalent bond, and the metal and non-metal is ionic. Okay. Now, as soon as you see diatomic, which is 2 of the same, I know it's not ionic, it's covalent. And covalent, when you do TICs, covalent means sharing of electrons. Okay? Now, what type of bond is in sodium bromide? So let's see where they are on the chart. We could do electronegativity differences, but if it's a metal, like sodium is over here and Br is over here. If it's a metal and a non-metal, I first check for that because I know right away it's ionic. I don't bother doing electronegativity differences. But if you did, it would be greater than 1.7, the value. Transfer of electrons. What does transfer of electrons mean? Ionic, right? Metal and non-metal. Now, this one will definitely be on your midterm. Another word for molecular is covalent bonding, which is 2 non-metals. Ba and O, let's see where it is before I start taking electronegativity differences. Oops. So, Ba is over here, and O is over here. So, metal and non-metal, what type of bond is metal and non-metal? It's ionic. And then if you write out this, ionic means that the electrons are transferred. Now here you have Na, P, and O. You have three things, Na, P, and O. And if we go here, Na is over here, P and O over here. So you have metal, non-metal, non-metal. So that means it's both. Now here you have silver, Ag is silver, and you see mobile electrons, you see a bunch of electrons in between, that's metallic bonding. Now when an ionic bond forms, metals are always losers. Metals lose electrons and they become positive. And if you forget that metals become positive, you could look at all the metals and you'll notice that they all have positive charges. Good? And then, who will form an ionic bond with Br? Well, let's see where Br is. Br is over here, so it's a non-metal. So we know ionic bonds is a metal and a non-metal. So we already have the non-metal, so you need a metal. So you need something to the left of the stairs. And Li, if you look, is over here to the left of the stairs. So that's your metal. And then ionic bonds, if you have K and I, the metal loses and the non-metal gains. And because Ki is an ionic bond, because you have K over here and then I over here, you want brackets. Ionic bonds always have brackets, and the metal loses, so there's no dots, and the non-metal will have, like these, the charges are wrong. That's silly. Remember I said molecular, you're definitely going to be asked. It's another word for covalent, which is two non-metals. This is the only one that's two nonmetals. All the other ones is left side, right side, left side, right side. So those are all ionic. Now, what pair will share electrons? Share electrons means covalent. So let's see. We have BAI and KCl. Ba and I is ionic because metal, nonmetal. KCl is metal and nonmetal. So that's ionic. So this one's ionic. That one's ionic. Li and I is ionic, and these two, Br and Cl, are right here. They're both nonmetals. Good?
Yes.
All right, next. Oops, I just erased it. Now there's an eraser there. Which is only covalent bonds? We want all non-metals. So I'm going to just pick the answer for you, C, H, and O. So if we look, C is over here. It's a non-metal. O is a non-metal. Even though H is on this side, it's also a non-metal. Good. And now, this means two electrons or one pair. And if you have a double bond, it's a total of 4 electrons or 2 pairs. Mobile electrons, you're going to find a metal alone. And copper, you should know, is a metal. Non-polar bonds. For non-polar bonds, it's equal sharing, so you want to pick 2 of the same, Br, Br. Non-polar bonds, pick the diatomic. At this point, you know, this is a review, just know that. Pick the diatomic, 2 of the same. Non-polar bonds is equal sharing, not transfer. Transfer is ionic. C mobile electrons is metallic, okay? Metallic bond, you pick a metal alone. Now, let's do 28. 2 of the same is a non-polar bond. 2 of the same is a non-polar bond. Nitrogen, you have to know, forms a triple bond, but you see how it's 2 of the same? It's a non-polar bond. And the reason why is if you look up the electronegativity values, you're always going to get 0. So ammonia here is polar. But anyway, if you want to double check, you look up those electronegativity values. I showed you where to get them, and you'd see it's polar. Okay? Now, we have P and Cl. So I looked up Cl before. We're going to look up P's electronegativity value. So P is right here. It's 2.2. And when you take the difference, you get 1.0. So you know it's polar. I write the word snap for polar. Polar means A for asymmetrical, so it's shared unequally. Polar means unequal. Non-polar bond, what I tell you to do, pick the diatomic. 2 of the same. Because you're going to get 0 as the electronegativity difference. Which has a polar bond? Well, 2 of the same is nonpolar. And when you have a metal and a non-metal with the brackets, that's ionic. So it's got to be that one. And you could check. You could look up Cl, look up H. And if you want bonds, you could always look up electronegativity difference. Do you remember what nonpolar bond is? Which one are you going to pick? You're going to pick the diatomic. Then, which is most polar? All right, well, now we have to look up electronegativity values. I know fluorine is 4.0. So when you take the difference here, you get 1.8. Now we need Br and H. The Cl I already know is 3.2 and 2.2, so this one's 1.0. And I'll just show you. I know the answer is going to be HF, but I'll just show you for Br. It's right here, 3.0. Oops, I kind of erased it. But we got the answer already. You would go through every choice, but I'm telling you it's HF to save time. Most polar, again, now you got to do oxygen and carbon. You know where I'm getting these numbers from. I showed you where to look them up. Oxygen and nitrogen, hydrogen and iodine. I just look them up and subtract. Look up HCl, look up H, and subtract. Now, what do they want to know? Most polar. So we have 0.8, 0.4, 0.5, or 1.0. So it's the most difference.
I'm sorry. Can I just use the pen?
Yeah.
Okay.
No problem.
It's down here?
It's right. You see it?
Yeah.
You just got to hold down the thing.